Hello there, college algebra students. This is Mr. Kashi speaking. This will be the second part of our notes on 0-4, which is on the nth root and real exponents. And this is where we're going to get the talk about rational exponents. So just starting up here at the top of the slide, squaring a number and taking the square root of a number are inverse operations. And the relationship can be used to express radicals in exponential form. So basically, you can take the square root and the square root of a number, but then you can make it into an exponent. So one thing here, like over here on the side, we could just do a couple of things, like the square root of x would be the same thing as x to the 1/2, and the cube root of x would be the same thing as x to the 1/3. So we're able to go back and forth from one another. But not everything is going to just be that straightforward. So you might have like the 5th root of x squared. Well, we could rewrite that as x to the 2/5, which gets, I hope you can just kind of see where we're getting the 2 from. The exponent from the original x is just going to be the numerator in our exponent. That is just kind of a run through of what we have here for radicals and exponents and how they are going to be used, and just a couple of different things. Also, these are a couple of good notes to have. So we can move on to an example. So here we have the 10th root of 32 and the 6th root of 2. And so here, there's just like anything in algebra, there's a couple of different ways that you can do it. I think the fastest way would just be to create fractions for exponents first. Okay, and so you'd have 32 to the 10th divided by 2 to the 6th, and here what I would do is I would almost take the 5th root of 32. So we're going to break that 32 up into the smallest that we can. So that would be 2 to the 5th. And that might not be straightforward on how you would just automatically know to do that. So if you have any questions, raise your hand and I can come around and kind of explain how I got that conversion. And then we just leave 2 to the 1/6. Okay. And then here, hopefully, you can see we're going to be doing 5 times the 1/10, right? And that would be 5/10, which would boil it down to 1/2 for our exponents there. So here we would have 2 to the 1/2 over 2 to the 1/6. Okay, and then what we would be able to do is use our quotient rule. Hopefully you remember from your last video or the notes that you took. So we could just do the 1/2 minus the 1/6 in the exponents, and that would get us 2 to the 1/3. And then you could leave the answer like that, or just so we're kind of practicing our conversions as well, you could convert that back into the cube root of 2. All right. So it seems like a lot. That breaking the 32 down into 2 to the 5th is probably the trickiest thing to recognize there. But hopefully the multiplication and these rules are kind of straightforward to you. The next one gets a little bit complicated, but I think we're going to go a different route with this one. What I would do is I would split up this x and these y's into exponents that are divisible by 4. So 21 isn't divisible by 4, but 20 is. So I'm going to do the 4th root of x to the 20, and then that one other x that doesn't have, we're just going to put it right next to it. And then same thing, 15 isn't divisible by 20, but 12 is. We can't go up to 16, but we can go down to 12. So we're going to go the 4th root of a y to the 12th times the 4th root of y to the 3rd. And we're doing that because they're evenly divisible by our fourth root here. So next, probably to be easier to see, would be to put these in exponent form. So this would be 20 divided by 4 times x to the 1/4 times y to the 12 divided by 4 times y to the 3/4. So hopefully you can see how this 20 divided by 4 would simplify nice into the x to the 5th. That x to the 1/4 is going to have to stay there. And the 12 divided by 4, that would be y to the 3rd. And then this would have to stay y to the 3/4. And that would, now we can clean that up a little bit. Usually we would put them back in radical form. And so in this case, we would keep x to the 5th and y to the 3rd. Those are now just regular exponential with variables with exponents. And now we would take that x to the 1/4 and put it back underneath the radical. So that x to the 1/4 would be x, and then basically bringing that down here, and then this y to the 3rd would be there. So this would be broken down into our simplest form now. Okay, so we were able to pull some of those fourth roots out, but not all of them. What isn't divisible by 4 had to stay behind into that radical. So that's it for our examples for this lesson. I will obviously be coming around helping you if you have any questions on these examples or questions on the assignment as well.